Welcome to CEC lectures. Myself Dr. Preeti Chakwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So as you are aware of the fact that within the series of Introduction to Programming using C++, the topic which we are currently studying is exception handling. And this exception handling, in the first lecture corresponding to exception handling, we have seen what is this exception handling, how it can be done, a macro level format. We have seen a general format, and we have seen the utility of this exception handling over the traditional methods of error catching. With the quick recap of the exception handling, we will begin with kind of programs and other nitty-gritties of this exception handling, which is the agenda of today's lecture. If you see the general format of try catch block, so first of all let me explain that we have three keywords in order to have this whole exception handling mechanism. In order to the three keywords are associated with this exception handling. One is try, another one is catch, and third one is throw. So try block is having all the codes which are suspicious of throwing an exception or which are needed to be monitored, and we have corresponding catch blocks. So why we have first of all we can have multiple catch blocks, and each and every catch block, which catch block is to be executed, either it is going to be the first catch block or the second catch block or the third catch block or maybe nth catch block, will depend on the type of exception which is thrown. If the type of exception which is thrown is matching with the parameter of the first catch block, that will be executed. If the type of exception which is thrown is of your type 2 argument, the second catch block will be executed. If the type of exception which is encountering or which is encountered or thrown is of type 3 argument, we will be throwing this catch third catch block, or similarly we can have n catch blocks. So basically when an exception is thrown, it is caught by its corresponding catch statement, and the code which is written inside the catch statement is going to process that exception. And there can be more than one catch statements associated with the try, and which catch statement is used to determine which case statement will be used is determined by the type of exception. Now that is whenever I am talking about the type of exception. So type of exception is the data type specified by the catch which matches that of the exception, then that particular catch statement is executed. So any type of data may be caught, including classes that is created. So we can have objects or we can have the exceptions corresponding to simple data types as well. Now if no exception is thrown, that means no error occurs within the try block, then no catch statement will be executed. It is not necessary every time for an exception handling code to have the catch statement executed. The catch statement will only be executed if there is a corresponding exception which is thrown. If no exception is thrown inside the try block, then no catch statement is executed. Also, if a statement is thrown and it is not finding the corresponding catch statement, then also the catch statement will not be executed. So there can be different scenarios depending upon the application. So this was about the two terms which are try and catch. But initially we have seen that in order to maintain this whole exception handling scenario, we have three keywords which are try, catch and throw. So general format of throw and why throw is being used, let's try to explore that. So general form of the throw statement is nothing but throw and then an exception. This exception could be anything, and then this exception will be kind of, we can say, matched with the catch statement, and wherever with the parameter of the catch block, and wherever it is going to find a match, there that particular catch block will be executed. So throw is basically there to generate the exception specified by that term exception. If this exception is to be caught, then throw must be executed either from within the try block or from any function called within the try block direct. So that means directly or indirectly. So what I am trying to say here is throw is there to generate an exception, but when this exception will be generated, this exception will be generated when this throw is executed. Now in order to execute this throw either has to be kind of placed within the try block, native try block we can say, or this throw can be placed inside a function and that particular function is called within the try block. So it could be a native throw inside the try block, or it could be a throw which is inside a function and that function is called inside within the try block. So it could be a direct call to that throw or to indirect call to that particular throw. Now whenever a throw is being executed, then exception is thrown and then that particular exception is handled by the corresponding catch statement, and we have already seen the general format of try catch statements. Now let's try to see one exact kind of real life program in which I have put throw inside a particular function and that function will be called in within the try block. So let's try to code that particular program. We have #include iostream.h and namespace standard. Then we have we can say created one particular function, and this is the exception, or this is the situation in which I am going to demonstrate the handling of the exception which is division by 0 condition. So we will be taking the function division is going to take two parameters, integer a and integer b, and if b is equals to 0, so at the in the dynamic situation at the runtime it is perfectly possible that b is given as 0 by a user, or maybe because of some calculation the value of b, which is our denominator, is coming to 0. So if b is equals to 0, then within this if block we have written throw, and within the double inverted commas we have written the exception. So exception here is division by 0 condition, and we will try to catch this exception inside the catch block, or we can say we will try to handle this exception inside the catch block. So if b is equals to 0, then we have seen then we have written throw division by 0 condition. Whenever there is a throw term which is encountered, the control directly kind of transferred to the catch statements and it will look for its corresponding catch statement. Now whenever I am saying corresponding catch statement, that means it will look for the parameter of the catch statement whose type is going to match with the exception type. That means here we have we can say a character, a complete string. So basically in this situation the throw will be looking for a particular catch whose parameter is a, we can say, character pointer or a character string, which is matching with this division by 0 string. And if it is not, if b is equals to not 0, then this block will not be executed, and if this block will not be executed, throw will not come into the picture, and simply A divided by B will be returned. So this is just a simple kind of function which is returning A divided by B in all the situations except when B is equals to 0. If B is equals to 0 is encountered, then it is throwing an exception. Now let's try to see inside the main function what is happening. We have seen we have kind of, we can say, hard coded the value of x and y, which are going to be give their values to A and B. So integer x is equals to 50 we have taken, integer y is equals to 0, and double z which is there to store the results is also taken as a 0. So within the try block we have called the function division, and as you have seen the function division, that function division is having the statement throw, or we could have directly used the throw statement inside the try block, but we have not used it directly. Instead we have used it inside a function division, and that function division is called within the try block. So here we have try and z is equals to division x comma y. So this division x comma y is a call to that particular function in which the value of x as 50, value of y will 0 will be passed to A and B, and when B is having the value of y which is 0, B is equals to 0 condition is satisfied. So within the block of this if, we have returned throw division by 0 condition. So this throw statement, now after this throw statement, it is kind of corresponding catch statement is to be looked upon, and if you can see we have returned the corresponding catch statement just after this try block, and I have already told you this, there should not be any statement between try and catch, and the catch statement is having a constant character pointer as the variable message, and it is going to kind of instead of C out we have written C error because this is an error message, so the message will be displayed. Now see, and there is a return 0. Now see what is happening. Let's say the kind of execution started, and execution always starts with the main. So main x equals to 50, y is equals to 0, and when within the try block z is equals to division x comma y, this will call the previous function, and within this function by becoming value of b is equals to 0 by the virtue of y, it is going to throw division by 0 condition. So whenever your system is encountering the keyword throw, it will start looking for the corresponding catch blocks, and the corresponding catch block is just available kind of we can say underneath the try block. It will take that particular catch, the variable MSG message is going to get the value from the exception, and the exception is division by 0 condition, which is written inside a double inverted comma. That means it is a string. So throw, we can say basically that's a constant character pointer message, or that's a string. So this message, now the throw, as throw has transferred the control to the catch, now the catch will be executed. That means catch is now there in the scene in order to handle the exception which is being thrown by the throw word, by the throw keyword basically, and that message, that is division by 0, will be printed, and finally you will have return 0. Now please try to understand that in the absence of this catch and try statement, if there is an A divided by B where the value of B is 0, what would be the possible scenarios which may happen. So if we don't have try and catch statement in such scenarios, your program is not going to give you a clean exit. So for the kind of an, we can say, a clean exit, we have to have this try catch block, which is an exception handling mechanism, in order to give the program a normal, a clean exit. Otherwise your program would have we can say interrupted quite abruptly, and the user will not get the proper message that what has happened inside the program and why this program is not working. Whenever this message is printed on the screen, that is division by zero condition, your program is getting a clean exit, because it is going to kind of execute this return 0 and the kind of we can say closing, a formal closing of the main function. Also, by printing the appropriate message, your user or your end user of the program is going to get a clear and concise message that what is happening inside the program and why this program has kind of terminated abruptly. So basically we can say the catch statement takes a parameter, and in this example we have used constant character pointer for a string, because we are throwing an exception of the constant character pointer. Now coming to what can be included inside the try block. So this try block can be as short as few statement, as we have seen in the example which we have looked on just now. Statement, just a few statements, maybe a function call, or it may encompass or it may enclose the whole function of code of the main function. So try block can be very, very small, or we can say the try block can be very, very large, having all the statements of the your main function. So that's no limitation on the try block. Now let us try to see or let us try to understand the concept of this exception handling with the help of one more example. So within this example we have seen we have taken simple namespace standard iostream.h, and within the main we have taken one x value which is a variable, and the value which is fixed for this variable is fixed as -1, and we have seen we have returned before try, we have returned the statement to be printed before try. Within the try we have kind of cout inside try, and the next statement of the try says if x is less than 0. So yes, x, the value of x is -1, and yes, it is less than 0. So that means this if block will be executed. Now when I am saying throw x, so that means I am throwing an exception of the type integer, because x is an integer. So now the corresponding catch will be looked for. So here the corresponding catch will be that whose parameter is of the type integer, and whatever is written after the throw which will never be executed, because the throw statement or the throw keyword will transfer the control from try block to the next kind of catch block, and the corresponding catch block will be looked for. So whatever we have written after the throw will not be executed, and hence this cout statement which says after throw will never be executed, and this statement will not be printed, because the moment throw is encountered, the control has been transferred to the catch. statement, and the corresponding catch statement will be kind of executed. After coming out from the catch, the control will retain over onto the next statement. So if there is a catch, that catch has been kind of, we can say, executed. Whatever is written inside the code will take place, and whenever there is an ending to the catch, the normal sequence or normal flow of the program will be followed. Also, one thing which is worth noticing here is within the try and catch block there is not any statement, and this I have already told you that there should be no statement between try and catch block. So here you can say the try is opening and within that see out, and then if statement, whenever try is closing at the last line which is available on the screen, immediately following the try statement there is a catch statement, and here the parameter of the catch is of type integer, because then only that throw which we have that throw statement which is throwing the exception of type integer will be handled properly on getting the corresponding catch statement. And after catch statement, so we have written catch integer x, and within that cout exception caught, and after that we have written after catch statement and will be executed. So whatever we can say output here, what output we are expecting is starting from the main statement x equals to -1 is perfectly fine. Then there will be a statement printed which says before try, then there will be a statement inside the try, then there is throw x, and after throw whatever is written will not be printed. Throw x will be handled by this catch, and within the catch you will say exception caught, and after the catch the statement which is written which is there to be printed, that is after catch will be executed, that statement will be printed. So finally we can say as output we have before try, inside try, exception caught, and after catch will be executed. And if you can see in the output, we don't have that statement which was written after the throw, because the statements which are written after the throw will never be executed. Now coming to the problem of having how many catch statements do a programmer need to write in order to handle all type of exception. For example, my try block is having so many statements. So if my try block is having so many statements, that means all those statements are basically suspicious of generating the kind of that runtime error. So we may have catch integer x, we may have catch constant character pointer message, we can have float x, and so on and so forth. So what will be the limit of how many exception or how many catch block a particular programmer need to write? So in order to solve this problem, there is a special catch block called catch all, and it is kind of represented by catch, and within the parameter list there is an kind of series of 3 dots that can be used to catch all type of exception. For example, let us say a program in which an integer exception is thrown, but there is no catch available which is designated to handle the integer exception. So the catch all block will be executed. So here you can see we have integer main, and within the try we have written throw 10. So throw 10, now one catch statement is there for character strings. So 10 is obviously not a character string, so it is not going to match with this first catch. Now there can be other corresponding catches here which are not matching with this type of exception which the throw keyword is throwing. Here my throw keyword is throwing an exception of type integer, and let's say we don't have any integer, any catch which is there to handle the integers. So what will be in this situation? So we have one catch all statement which is there, and it is written as shown on the screen, catch, and within the parameter we need to give 3 dots. So this catch with 3 dots exactly means that catch all. So whatever exceptions which are not caught by kind of other catches, similar as in this condition we have a catch corresponding to character, we don't have a catch corresponding to integer. So that integer exception will not be handled by the catch corresponding to character. So this catch all statement or this catch all block is going to take this exception or is going to handle this exception, and this will be the output, that is default exception, because this catch all block will be executed, and hence your program will be having a clear and concise exit, we can say. So within this lecture we have seen one example of your how these throw statement and try and catch blocks will be there. There can be multiple catch blocks, which particular catch block will be executed, and what if your program is not able to find the corresponding catch block, then there is a rescue mechanism which is known as catch all mechanism. All these fundamentals we have seen in this particular lecture, and here is a list of references used for the preparation. Thank you for a patient hearing.